today we are going to do some more questions based on gamma functions. Using the property of gamma function, prove that 0 to infinity x to the power 2s plus 1 e to the power minus ax square dx is equal to s factorial over 2a raised to the power s plus 1. So how to prove this question? Now let us put ax square is equal to u. So x square is equal to u over a. X is equal to 1 root u by a. Differentiate both sides. Dx is equal to 1 over 2 under the root u by a 1 over u into du. Now let us put the values in this integral. So you get 0 to infinity u over a 2s plus 1 by 2 e to the power minus u half under root a over u into 1 over a into du. Take the constant terms out and combine the terms of u. Now you can check it. U to the power is 2s plus 1 by 2. This is what? Plus half minus 1. So if you solve this relation, this is equal to u raised to the power s. So we can also write u raised to the power s plus 1 minus 1 into du. Now why we are writing this? Because we know that if we write this term, then this is equal to gamma s plus 1. And by definition, it is equal to s factorial. So gamma s plus 1 over 2a raised to the power s plus 1 from this integral, that is equal to s factorial over 2a power s plus 1, and that is equal to the right hand side of this equation. And let us do the next question. 0 to infinity x raised to the power 2s e to the power minus ax square dx, which is equal to gamma s plus half over 2a power s plus half. Now how do we prove this equation? Let us take left hand side of this integral. Put ax square is equal to u. So x is equal to 1 root u over a. Differentiate both sides. You can get dx is equal to this. Put the values in this integral, 0 to infinity. The whole term instead of x, put under root of u over a. Rest of the terms like that. Constant terms out and combine the terms of u inside. So we get u s minus half e to the power minus u, or it is half a to the power minus s plus half e to the power minus u, and this can be written as what? S plus half minus 1. Since this is nothing but equal to gamma of s plus half, therefore we can write half a to the power s plus 1 by 2 gamma s plus 1 by 2, and this was the right hand side which was to be proved in this question. Now these are some of the properties which we have used for gamma function. Now let us take another case. This is infinite product form, which is called as stress form. Gamma of z is equal to 1 over z e to the power r to the power z summation m equal to 1 power to n 1 plus z over m e to the power minus z over m, where r is equal to limit n tending to infinity, pi is equal to m equal to 1 to n 1 over m minus log n, which is 0.577156. This is called Euler-Maccheroni constant. The infinite product form can, according to the infinite series form, it is gamma z. We know this is what the definition of gamma function. Now invert the above equation. So we get 1 over this. All the terms are reversed. So we get z plus 1 and that term up, and this is in the denominator. Multiply the above equation by the expression 1 plus 1 over 2 plus 1 over 3 into z. This is exponential. So summation m equal to 1 to n e to the power z over m, or summation m to the power n e to the power z over m divided by this term, that is gamma z. This is equal to z into exponential of the whole term minus z log of n, summation m equal to 1 to n, 1 plus z over m. Now this can be written as z exponential z into this term minus z of log n, summation m equal to 1 to n, this term, and this e to the power, that term is taken to the right. Right? So this is further equal to z e to the power rz summation this, because we have already this expression written which is given in the question, that this r is equal to so much. So we can write this z e r z by summation 1 to m, 1 plus z by m e to the power minus z by m. So what is gamma z? That is just reverse of it. That is answer. Next question, very important. Using the infinite product or Weierstrass form of gamma function, show that gamma z into gamma 1 minus z is equal to pi over sine of pi z. The Weierstrass form of gamma function is e to the power z over m, z e to the power rz, and summation m equal to 1 to n into 1 plus z by m. Now replace z by minus z. So everywhere where it was z, change it into minus z, and let us write this as equation number 2. Now multiply equation number 1 with equation number 2. So we get gamma z, gamma minus z equal to minus of this whole term. Just multiply the two. So this is further equal to, because see e to the power, that will cancel out, z and z will multiply, negative sign comes. This is minus z to the power minus 2, rest of the term in the denominator. Now also we know that sin x can be written as x summation m equal to 1 to infinity 1 minus x square upon pi square m square. Let x is equal to pi z, m is equal to n. So this can be written as sine of pi z equal to pi z 1 to infinity 1 minus pi square z square upon pi square n square. Or take this term to the left hand side, you can write this as equation number 4. So you can check it, this whole term is equal to sine of that. Put it into the equation number 3. So third equation gives you gamma z into gamma minus z equal to z minus 2 pi z over sine of pi z. So z into gamma z into gamma minus z can be written as minus pi over sine pi z. This is z minus 1, so that will be taken to left hand side. Or gamma z plus 1, gamma's minus z, that is equal to minus pi over sine of pi z, because this whole term can be written as what? Gamma of z plus 1 by definition. Replace z by minus z. So you can write here gamma z, gamma 1 minus z, this is equal to pi sine of pi z, which proves the answer. Next comes, what are beta functions? The beta function, beta, which is dependent on the two variables m and n in terms of definite integral form, can be written as 0 to 1, x to the power minus 1, m minus 1, 1 minus x power n minus 1 dx. Symmetry property of beta function. Beta of mn is always equal to beta of nn. Now how to prove this property? So if beta is written like that, let 1 minus x is equal to y. If x is equal to 0, y is 1, x is 1, y is 0. Or differentiate, it is dx is equal to minus dy. So change the limits, everything in terms of y. So we get the expression 0 to 1, y to the power n minus 1, 1 minus y, m minus 1 into dy, which is nothing but equal to beta n m, because beta was given by this, so now it is equal to beta n and m, so that is the property. Another property, beta function in terms of definite integral, beta mn 0 to 1, this is what the expression is. Let us take this as first term, this is the second term. First case, when n is positive, integrate the above equation by parts. The first term as it is into the second term, integral of sec 0 to 1 minus integration of 0 to 1, that derivative of the first term and integral of the second term. So we can write beta mn, which is equal to n minus 1 divided by m. Since this term comes out to be 0, this is 0 to 1, 1 minus x n minus 2 x to the power m dx. Now likewise, if we continuously integrate the above equation by assuming m and n as positive integers, we can write n minus 1, n minus 2, n minus 3, so on, 3 to 1, m plus 1, m plus 2, m plus n minus 2, 0 to 1, x to the power m plus n minus 2 into dx. Now this gives you integration like this, 0 to 1. So we can get this as the whole quantity, which can be written as what? N minus 1 integral, factorial over this whole term. That means this is another way of writing when you extend it to different parts. Now, case number 2, if we f m is positive, integrate that by beta function by taking, this is the first term and this is the second term. So we will get this relation, n minus 1 factorial, m minus 1 factorial over m plus n minus 1 factorial. Another form of beta function. Let us write x to be as y over 1 plus x, y. 1 minus x will be equal to this. So what is dx? That is equal to this much. So write in beta, this becomes y to the power m minus 1 over 1 plus y power m plus n into dy. Now let us take one application for this. Prove that x to the power 8 into 1 minus x to the power 6 over 1 plus x to the power 24 is equal to 0 from 0 to infinity. Now, let us see how do we prove it.